Okay, welcome back everyone. Gonna move on, work on second operation. So the first thing that we'll do, create a new toolpath group. So we're gonna right click on the machine group, come down to groups, new toolpath group. Next we'll create a new plane. So we'll go down here to our planes tab, from solid face. Click on the face there, and that is the orientation that I want right there. Green check. And I'm going to move the coordinate system to the corner of the part. So I'll press the reselect key or click on it. Zoom in and snap to the corner. Green check. Okay. Hit the WCS, the C, and the T. Okay, so we'll name our plane OP2. Back to our toolpaths. First thing we'll need to do is face the material that's left down here. So choose the facing toolpath. For my geometry, I'm going to use that same rectangle from the first operation. Two-inch face mill is fine. Okay, match my numbers. Shouldn't need any depth cuts. There's not a lot of material down there. One thing we have to be careful of is the depth here. It's going to put -1 inch because that's where the wireframe geometry is down there. So we're going to change that back to a 0. Maybe we will give it a depth cut. Hundred thousandths. My top stock is 200. Fluence on. Green check. Alright, so now the part is faced. Now I want to take care of this step here. In order to do that, I'm going to draw a line from this corner to this corner to give me some geometry for the toolpath because it's broken because of that slot. So I'm going to wireframe line endpoints. Click that corner, click that corner. Green check. Okay, so my toolpath is going to be a contour, so toolpath, contour. Click the geometry. Use the 1/2 inch end mill for this. Can match my speeds and feeds. wear compensation, 2D contour. I will use depth cuts just so that we can do a finish pass on the floor here. So my max rough step is going to be 0.25 and 1 finish pass at 10 thousandths. Lead in, lead out is good. And I'm going to need some multiple passes because it's an inch long. So I'm going to go with 4 finish passes at 1/4 inch and 1 spring pass. Depth is minus 0.25. That was automatically filled again because the geometry is at the Z depth we want. When it's on, you can check. A little message here. Okay. So didn't like that. So we'll change finish passes to all depths. That should fix it. So again, I just went back into the parameters, into the multi-pass parameters, and changed the finish passes to all depths. Alright, so that's done now. And next, we'll take care of this dovetail cut. This is the area that actually holds the indicator when this thing is finished. So what I'm going to do for this is I want a line that goes right down the middle, and just because I know I don't want to use the actual solid geometry, so I'm going to go to wireframe, click my line endpoints, there to there, that. So now I have the line right there. So now I can draw another line from the midpoint this way. So go from the midpoint. Okay. And you see that it snaps to perpendicular. So what I'll do is I'm going to force it to do a length of 1/2 inch, 0.5. And then I will snap to perpendicular like this. And I can click out here, it doesn't matter because I already locked it to 1/2 inch long. Click that. Green check. Now I have the line going down the center. So we're going to use 2 tools to take care of this feature. First we'll rough it out with an end mill. and then we'll come back with the dovetail to finish it. So that's going to be contour. I'm going to switch to solid selection, single edge. Click that edge and this edge. Green check. For this one I want to use a 1/8 inch end mill. Select library tool, filter to my flat end mills. 1/8 flat end mill. Okay, you can match my speeds and feeds. Cut parameter is going to be where. I'm not going to use any depth cuts. Lead in, lead out. I'm going to make it smaller. I'm going to go to 20, 20, and then I'm going to adjust the length of the contour by about 40%. I don't need any multi-passes. And for my depth, right there, minus 60 thousandths. And coolant's on, green check. Alright, that looks pretty good. So now the only work that the dovetail has to do is just a little bit of the undercut there. Alright, so for that, it's going to be another contour. This time we're going to use wireframe selection and a single piece of wireframe geometry. Clicking on that line that we drew. Green check. For my tool, right here are dove mills. You may not have any, like I don't. That's okay. Get X out of there. And back here we can do a right click, create tool. Dove mill. You can either click the define tool geometry or next. Either way, get you here. Our cutting diameter is going to be 0.25. Our shank diameter, you just have to get these numbers right and then the picture will show back up. Alright. So if you use these numbers, should get this result. And that's good. Finalize properties, so 0.25 dovetail cutter. I'm going to change it to a 2 flute. Finish that. Oh, yeah, that's right. Okay. Match my speeds and feeds. For the cut parameters, our compensation is going to be off because we want the center of the tool to follow that line. And we're not going to do any lead in, lead out. So we're going to extend 75% the start and the end of the contour. That'll effectively give us a lead in and a lead out. We don't need the curve or anything because we're not using wear compensation. Okay. Linking parameters. Minus 60 thousandths. And coolant is on. Green check. Do a little back plot real quick just to make sure that I extended it far enough. And there we go. Okay, that looks good. And the last thing that we need to do is deburr. So we're going to need to draw a little bit more geometry for that. Coming across here. We could use the solid, but then it's going to end, pick up, and re-enter again. We don't really need that, so I'm going to go to wireframe. And I'm going to use curve 1 edge. I'll use that for this and for this. Then I'm going to green check. And I'm going to choose line endpoints. This corner to this corner. Green check. And then I'm going to do one more. I'm going to do a rectangle. I'm going to choose this corner and this corner. I want to leave a nice sharp edge here, so I'm not going to deburr this edge or this edge. So I'm just going to have the chamfer mill go around this upper rectangle, and then it's going to do as much as it can around this profile here. Obviously we have the wall here, so we can't go all the way up to the wall. Alright, so contour. Choose the upper rectangle. Tool is going to be our 1/4 inch chamfer mill. Match my speeds and feeds. Computer compensation. 2D chamfer routine, 10 thousandths with the 50 thousandths offset. Going to change my lead in, lead out back to normal, so remove the adjustments and reactivate the entry and exit. Alright, linking parameters. Our depth should be absolute 0 for that top rectangle. And coolant is on. Alright. Now we'll do this bottom one here. So one more contour. This time I want to use the partial chain, because now all 4 of these are connected. So if I used the regular chain, it's going to grab this one too. We don't want that. So with the partial chain, I'm going to select my first entity, as it says here. Then I'm going to select my last entity, which is over here. You don't click the one in the middle. First and last. Green check. Tool is going to be the same tool. Quarters chamfer mill. Speeds and feeds are the same. Cut parameters the same. Lead in, lead out. We're going to have to actually switch back. So take away the entry and the exit and adjust. And we're actually going to shorten 60% to be safe. So shorten 60% on both sides. Start and end. No lead in, lead out. Alright, linking parameter minus 0.25 in absolute, or it could be incremental 0. Either way. Coolant is on, green check. And then if we do a little back plot, we can see that the tool comes down close to that wall but not touching it. Okay. Save it. And do a quick little 3D verify. Okay, looks good. And that's that. We'll see you in the next operation.